Alright, welcome you guys. We're going to be talking about unions and intersections of sets. Okay, so some major vocab in here that you do need to know. We do need to know these three bad boys. Okay, disjoint sets, intersections, and unions. Okay, so this all came about the idea from a man named John Venn, who lived in England. Was a pretty cool cat. Let's pick a different color. Let's go green. Okay, and he wanted to count elements in a set. And what that actually was he just wanted to count items, just count them out and just see how many he had and see if there's any overlap and how he could organize his thought. And he was able to find out a way to do that, and what that was to come up with one of his own inventions called the Venn diagram. Okay. And that's basically the normal one is two circles overlapping. In truth, you could actually have a whole bunch overlapping and just work with it. Okay, so let's say set A and set B are right here. This is your normal Venn diagram. Okay, all right. Now, and then out here would be the complement of A and B. So it'd be A apostrophe and, well, there's actually a symbol up there. It is. Haha. 2 font 239. Okay, and it's going to look like this. So this is kind of cool. All right, so that's just that information out there. Now this just basically means not A and not B. Okay, so in other words, the opposites. Okay, all right, and it's just the complements of what's inside the circles and everything. Okay, so just to talk about all the stuff, just the intersection and everything. Okay, let's say that we had the numbers 2, 4, 8, 10, 12, and then we also had 1, 3, 5, 6, 7, 9, 11. Okay, so let's say we had all the numbers 1 through 11 in here, and I know I forgot the 6 over on the other side. Okay. All right, so I have all the numbers 1 through 12. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. Okay, and I just have these numbers over here. All right, now let's say I actually gave some names to these. Let's say that this was the multiples of 2, and that this was the odds. Let's just say odd numbers. Okay, between there. Now, if you notice the multiples of 2, okay, 6 is actually both, well, 6 would be over here originally. Okay, well, no. 2, these would never intersect. So we would call this disjoint. Okay? So this would be an example of disjoint. Okay? They don't intersect. You have the multiples of 2, hint, which are evens, and the odds. Now, if I were to change something, let's say this was the multiples of 3. Okay? This B set right here. Okay? Then we would no longer say disjoint because there's actually some unique things that are shared. Okay, so in fact, 6 and 12 would both be a multiple of 3 and a multiple of 2. Okay, and so what we would do is we would call this entire part, now this has two names. This entire part is a union, the union of the two numbers. Okay, and plus they kind of intersect. And then this part in the middle we would call the intersection of the union. Okay, now if you notice, I was able to move the 6 and the 12 over from A to the middle of A and B, the intersection. Okay, can I always do that with numbers? Yes. Now, when I'm counting up the amount of numbers in here, I'm going to count 6 as both an element of A and B if I leave it over here. Okay, whereas if I put it right here, I'm only going to count it once because I know it's counted in both categories. Okay, now that's huge in understanding how to count the items. Okay, now you could always make your Venn diagram and then just literally go 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. And you would say, oh, there's 12 numbers. Well, duh. It's the numbers between 1 and 12. 1 is the multiples of 3, and 1 is the, well, speaking of multiples of 3, let's get rid of that real fast. Okay, if this is just multiples of 3, then I have to move these numbers out. Just thought about that. That's amazing. Aha! Now that makes more sense because you're probably sitting at home going, oh, wait, what is this going on? Okay, so now what I've done is I moved these to the complement area. Okay, so these are neither A nor B. 1 is neither a multiple of 2 or 3. Neither is 5, 9. Well, 9 is. 9 is actually. What am I doing? There we go. Okay, let's double check it real fast. Yep, those work. Okay, so everything's just listed right in here. All right, now if I had to do union, I would go, okay, I know there's 12 numbers total. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I'd make sure they fulfill both statements, and I'd make sure that the intersection is filled up nicely. Okay. Oh, shoot, come on. Delete. There we go. Okay, so I have everything all set up, so I could count up the items, and I know there's 8. Okay. So I would say A union B is going to be there's 8 numbers in that set. Okay, so that's pretty simple. Now if I wanted to go A intersection B, and that would be this upside down one, so Alt 239, that would be 2 because there's just 2 numbers in that set, the 6 and the 12. Okay, so that one's just pretty easy to set up and stuff. Okay, now this one is kind of hard to do because there are formulas. Some people will say, oh, if we're looking for union, they say, oh, just do add and just work your way across there. That works for disjoint. Okay, so if I have disjoint, okay, disjoint sets, all right, if I see A union B, I could just go the sets of A plus all the things in B. Okay, now if I have non-disjoint, I don't think they call that in the book. Okay, in order to do the union, A union B, it will be A, this number of elements in set A, plus the elements in set B, minus, this is important, A union or A intersection B. Okay, that's important. Why do I do it that way? I'll show you. Okay, all of the items in set A, okay, let's just say this, it's 2, 4, 6, 8, 10, and 12. Okay, now if I add that with the elements in set B, B is going to be 3, 6, 9, 12. Okay, if you notice, here's something really unique. I'm actually double counting 6 twice. I'm counting it once here and once here, and I'm also counting 12 twice, once here and once here. And so because I'm counting it twice, I need to subtract it from the original. So what I'm going to do, and I just realized I used the wrong notation. Let me use the curly braces. Okay, so I have this all set up like this. Okay, And so what I need to do is I need to subtract that. So I'm going to subtract the set of 6 and 12 from it. Okay? And I'll actually get my 8 numbers. And that's the only way you can ever get the 8 numbers of this set, of a disjoint or non-disjoint set. Okay, now if it's disjoint, I would just add up everything. Okay, I would have no intersection, and therefore I just add the numbers on the left, the numbers on the right, and I'm good. But if it's non-disjoint, you do have to subtract the intersection. Okay, the intersection is really easy to calculate every time. It's just the number in the middle, and that's usually what we're given to you. Okay, so you just have to take your time when working with sets. If you do, Venn diagrams really pay off in the end. Okay, thank you guys very much, and have a great day.